Dear students, welcome to part 3 of quantum mechanics. Today we'll be discussing about time independent Schrodinger equation or steady state form. The one-dimensional time dependent Schrodinger equation we have of this form, equation number 5. And in stationary field cases, the wave function psi can be replaced with two functions, the product of two functions. The first function depends on x and the second function depends on t. So we can write psi as the product of psi of x and phi of t. That is equation number 6. Note the change in writing psi on both sides of the equation. Now we will differentiate equation number 6 with respect to x. We get this form and here phi of t is a constant. Now we'll differentiate once more with respect to x. So we get dou square psi by dou x square equal to phi of t. As I told, it's a constant, phi of t into dou square by dou x square of psi of x. And we can write in simple terms that dou square psi by dou x square equal to phi of t into dou square psi by dou x square, that is equation number 7. Now we will differentiate equation 6 with respect to t. Earlier it was with respect to x, now it is with respect to t. So dou psi by dou t equal to psi of x into dou by dou t of phi of t, and here psi of x is a constant. And in simple terms, dou psi by dou t equal to psi of x into dou phi by dou t, that is equation number 8. Now we will substitute equations 7 and 8 in equation 5. So we get this form and we divide throughout by psi of x into phi of t. So we get IH cross into 1 by phi of t into dou phi by dou t is equal to minus h bar squared by 2m 1 by psi of x into dou square psi by dou x square plus v. Here please note that the LHS is a function of time alone and RHS is a function of x alone. So we can separately equate each side to a same constant. Let me just take it as k. That is IH cross into 1 by phi of t into dou phi by dou t equal to k, and the right hand side is also equal to k. Equations 9 and 10. Now we will take equation 9 alone first. Rearranging and integrating, we get the expression for phi of t as e raised to minus I by h bar k into t. That shall be equation number 11. And using this result in equation 6, we get psi equal to psi of x into e raised to minus I by h bar k into t. This equation we will differentiate with respect to time. So dou psi by dou t is equal to minus I k by h bar into psi. And we will cross multiply. So we get k psi is equal to IH cross dou psi by dou t. Now we will compare this equation with equation number 2 we already had, that was E psi equal to IH cross dou psi by dou t. We find that k is identical with E. Now using equation 10, here we are going to use equation number 10. So we get minus h bar squared by 2m 1 by psi of x into dou square psi by dou x square plus v is equal to E. Earlier it was equal to k, now we will write as equal to capital E. And we'll multiply by psi of x and rearrange. Finally we get this form. And dou square psi by dou x square plus 2m by h bar squared into E minus v psi equal to 0. That is equation number 12. And this is Schrodinger's time independent equation in one dimension. And in 3 dimensions, the form is, instead of dou square by dou x square, it will be del square psi plus 2m by h bar squared into E minus v psi equal to 0. This is called steady state form of Schrodinger equation. Thank you.